The principle behind time value of money is $1 today is worth more than $1 tomorrow. In fact, that one sentence pretty much sums up what the time value of money is. If you invest $1 today, hey, you're going to earn interest on it. You're going to have more money in the future. So there is a trade-off between current and future dollars. What rate of interest would induce you to give up consumption today and save it for the future when you will have more dollars? And you do make that decision based on the rate of return. In fact, when interest rates are low, people tend to save less. When interest rates are higher, people tend to save more. The rate of return that you earn on the money that you invest, that's the interest rate. Well, managers are doing the same kind of things. They invest money today in assets that are going to generate cash flows in the future. A basic problem that's faced by financial managers when evaluating new investments is figuring out what's the value of future cash flows. Now, part of the deal with time value of money, if I said, I'm going to give you $5,000 today or $5,500 today, hey, no problem. I think everybody would say, I want more money. I'll pick the $5,500. So we have two different magnitudes at the same point in time. Very easy decision. On the other hand, if I said I'm going to give you $5,000 in 2 years or $5,500 in 4 years, now you've got different magnitudes at different points in time. Now you need an interest rate. Now you need to make the calculations to determine which is the better deal. We're going to be looking at present value, which says what is the value of future cash flows received now, or future value, what is the value of money invested today at some point in the future. And again, that interest rate is an exchange rate between early money and later money. And as is unfortunate in finance, there are often multiple names for the same thing: interest rate, discount rate, cost of capital, opportunity cost of capital, required return. We'll be using all of these terminologies throughout the semester to indicate the rate at which we are going to compare current cash flows with future cash flows. So again, many different ways to refer to the interest rate, but the point is, if I invest $1 today, I'm going to earn interest during the year, so I'm going to have more than $1 in the future. To show the power of compounding, 1626 Manhattan Island was purchased for $24, but if you took that $24 and invested it at 10%, you'd end up with many, many multi-trillions of dollars, more than enough money to buy the world. This is an example of how powerful the time value of money is. Einstein said that the greatest mathematical concept is compound interest. Looking at the interest rate, again, we use that interest rate to exchange money over time, to equate a sum today with a sum in the future. We assume that the interest rate for borrowing and lending is the same, and that interest rate factor, 1 plus the interest rate, is the rate of exchange between what we're receiving today and dollars in the future. So again, it's dollars in 1 year versus dollars today. Let's look at an example. You have an investment that's going to cost $100,000 now and will give you $105,000 at the end of a year. And again, let's say we've got an interest rate of 10%. Well, at an interest rate of 10%, $100,000 times 1.1 is $110,000. But we're only making $105,000 from this investment. So it is not a good deal. We should be getting 10% for the investment. We're only getting 5% for the investment. So if we take this particular investment, we will lose $5,000 over the course of a year. So let's look at what we would get, $100,000 multiplied by 1.05 at an interest rate of 5%. We'd end up with $105,000. That's compounding. 100,000 times 1.05. That's the principal plus the interest that I would receive after 1 year. Well, what's it really worth? Let me discount that 105,000 back 1 year. I discount it using the discount factor of 1 plus the interest rate, and 10% is the appropriate interest rate. So $105,000 divided by 1.1 is only $95,455. So if I make this investment, we saw earlier I'm losing $5,000. We can see with this calculation that such an investment would only be worth $95,455. If I paid $95,455 for this investment, it would be a fair deal. At $100,000, I am overpaying for this investment, and I should not take this investment. Present value, we are present valuing a number. Future value, we are future valuing that same number. So again, two different ways with the same goal and the same outcome of comparing cash flows now versus cash flows in the future. In compounding, I took a sum of money in the present. I multiplied it by 1 plus the interest rate to get a sum of money in the future. The opposite of compounding is discounting. In discounting, money received in the future is worth less than the future price today. I need a discount rate in order to figure out what it's worth today. I turn that discount rate into a discount factor, 1 divided by 1 plus the interest rate, and use that to discount a future sum of money into today's dollars. Very important to construct a timeline. It sounds like a baby step, but it really is the right way to begin to see when you are receiving the money. Also important to put a negative sign in front of anything that you pay or invest or save, and a positive sign in front of anything that you receive. So when you read a problem, look and see when you're getting the money. In almost every problem that we will do, we will assume year end. So in this particular problem, we will receive $10,000 a year from now at the end of the year, December 31st, and another $10,000 2 years from now on December 31st, again, assuming today is January 1st. Now, let's look at these compounding factors and discounting factors. Future value. Let's look at what this chart says. First of all, it says that future value factors are always greater than 1, that a dollar I receive in the future is worth more than the dollar today because there will be compounding over that time period. I'm going to earn interest on my investment today, and it's going to be worth more in the future. The larger the interest rate, the larger the future value factor, and the larger the future value at that point in the future. I look at this, hey, I'd much rather have 20% than 15%, and 15% is better than 10%, and so on. This is related to risk and return. While I would love to have a 20% return, I'm going to have to take a lot of risk in order to earn that 20% return. I'm still going to have to take a lot of risk to get 15%, and sometimes these days in a low interest rate environment, even 10% is difficult to achieve. Now, if you notice that first line, the 0% line, that is, what if we didn't have an interest rate? It didn't exist. First of all, this course would be a lot shorter. At a 0 interest rate, it says time value of money doesn't matter, that a sum of money today or a year from today or 20 years from today is all worth the same. Again, we do have an interest rate. Money is worth more in the future because of compounding, so we do need to make these calculations. And the third point to observe is that the longer the time period, the larger the future value factor and the larger the future value. So the longer I can invest my money and let it earn money, the more money I am going to be making. So higher interest rates, longer period of time, higher future value. Now let's look at that compounding factor, the composition of interest over time. Let's say I started with $1,000. I'm going to earn simple interest on that original $1,000, and that's going to build up assuming I leave it all in the investment over time. But on top of that, I am going to earn interest on the interest. That's compounding, that I can earn additional interest because I've left that original interest in there, and then I will earn interest on the interest. And that's what Einstein was referring to when he said the power of compounding, that again, your money can increase very quickly because of that ability to compound. Next, let's look at present value factors. Present value is always less than 1. 1 is what you get right now. Tomorrow it's going to be a little bit less. The day after that, a little bit less. So present value factors are always going to be less than 1. Present value is always going to be smaller than future value. The larger the interest rate, the smaller the present value factor and the smaller the present value. This is a little bit less intuitive. If the interest rate is higher, then the money is going to earn more over time. So it's going to take less money to start with to earn a certain amount in the future. Notice also the longer the time period, the smaller the present value factor and the smaller the present value. The more in the future that you'll receive the money, the less it's going to be worth today. It has a longer period of time to earn interest. One of the most important takeaways is that there is an inverse relationship between the interest rate and present value. By definition, the investor is indifferent between the present value now or present value in the future. The investor can invest the present value now and it will grow to be that future value. If interest rates are higher, a smaller amount needs to be invested today to reach a particular future value. Now, one of the saddest facts about time value of money is that it proves that time travel is not possible. Some of the best science fiction stories have been about time travel. And let me explain why this is the case. Suppose there were time travel into the future. I could put $100 in a savings account, let's say at 10% for illustration purposes, leave it in there for 7 years, and it's going to about double. So $100 today is going to double to $200 in 7 years. If time travel were possible, I would deposit the $100 today, zip 7 years in the future, withdraw $200, zip back to the present, redeposit the $200, zip forward 7 years, and have $400 until I had infinite wealth. The time machine would be a money machine. So if everyone had access to time travel, the country would prosper. Again, we'd be making money and money and money. Now, since interest rates are not 0%, time travel is just not possible. Now, I told this example in class once, and a student did contradict me, correctly contradict me, a student who knows much more about physics than I know, that time travel into the future is a very possible concept. In order to travel into the future, all you would really need to do is to go fast. Time is relative due to velocity. The twin theory says, say you've got two twins, one's on Earth, the other is traveling in space near the speed of light for 10 Earth years. When the traveling twin gets back to Earth, no time will have passed, but 10 years would have passed on Earth for the twin who stayed on Earth. So essentially that means you can travel into the future. So while the money machine wouldn't necessarily work, you could invest a small amount of money today and with compound interest travel into the future and have a huge sum of money when you get back. So the moral of that story is, when you travel into space, make sure that you invest as much money as possible in your bank before you leave so you will be very wealthy when you return. The net present value rule that we will be using very extensively in future chapters says that the net present value is the present value of the benefits minus the present value of the costs. Typically, the benefits occur sometime in the future, and typically the cost occurs today. So what this says is, if you're making an investment decision, you want the alternative with the highest NPV. That's equivalent to receiving that NPV in cash today. A very common financial decision is whether to accept or reject a project. Because rejecting the project generally has an NPV of 0, if there are no new costs or benefits from not doing the project, the NPV decision rule implies that we should accept positive NPV projects. Accepting them is like getting their NPV in cash today, and we should reject negative NPV projects. If we accepted a negative NPV project, that would reduce the value of the firm, and we want to increase value as much as possible. So in general, that NPV principle says that doesn't matter what our preference is for cash today versus cash in the future, we should always maximize NPV first. Whatever alternative gives us the most value, wherever the benefits exceed costs by the largest amount, that is the project that we should choose. We will be looking at the NPV principle relative to stocks, relative to bonds, and relative to the projects that a firm is looking at accepting or rejecting.